I'm going to join this and then I'm going to share my screen. All right. So we are kind of at the end of our semester here, our last few weeks. So when we're looking at these last few topics, you might not get that super warm, fuzzy feeling like you totally understand. And that's okay, because this is an intro class and you're going to have probably C# programming and probably Java programming and JavaScript programming and all those other programming classes to get that nice, warm, fuzzy feeling. But maybe you can get it today. We're going to try. But we're going to move quickly. So I'm going to bring up this presentation that talks about arrays. It should be close to that one that's on Canvas, but it might just be a little bit different. Arrays actually have lots of different names. That's helpful. In C# and in Java a lot, we call them collections. In Python, we call them lists. And in really old programming languages, like COBOL, they call them tables. We don't use that term anymore because tables became a database term as things have changed. But you'll see arrays, collections, lists, tables, all of those terms synonymously referring to the same type thing. So that's okay, we can handle it. It is all of those things. So first we have to declare an array. Just like we have a variable, we declare our variables in our pseudocode. We found that Python lets us get by without an actual declaration because it figures out the data type on its own. But I'm normally going to use some sort of declaration, like data type and then open and close square brackets. So these square brackets up here, these are really important. They indicate that we're working with an array. So if you see those square brackets, you know you're probably looking at an array. So this declaration here is just a sample. Right below it is an array of integers. The keyword int comes before the square brackets, and then the variable name, array of integers. Here's one where we say that this array of integers is going to have 10 integers in it. Here's one where we say we're going to create a color array, an array of colors, and it's going to have 6 different colors in it. So we can think about arrays in lots of different ways and lists. So here's our array. Here's an array with 6 entries. Every time we work with an array, it's kind of a way for us to have more than one value. So think about it. If we've written a program that prompts a user for a cost, right? We have one cost, just that one item. Well, what if we want to keep track of several different costs? The first item's cost and the second item's. Well, we could do that in an array because an array lets us keep track of multiple things of the same type. Whenever we create an array, it gets allocated in memory and it has a slot, basically a spot for every entry, every piece of data that we've said can fit in the array. For every one of those slots, there's a numeric pointer to say, how do I get to this data? Well, I would use pointer number 1, index number 1, or down here, index number 3. Notice that when we define indexes, these pointers into our array, we start with the number 0. So this array has 6 entries, but the highest index number that we are going to see in it is 5. Now, after we declare an array, we have to initialize it, put some data in it. So we can do that in lots of ways. We can specify the array name and then the pointer location, like position 3 is equal to something, some variable. Here I'm saying the first position in the array of integers is equal to 3. Here I'm saying that the first position, item 0, in the color array is equal to some random color. This entry down here, I'm saying I have an array of colors named my colors, and these are the entries 0, 1, and 2. So I'm setting up my list. Now, after I ran that statement on the previous screen where I set a color array index location 0 to a random color, my color array now has an entry at index position 0. It got the color orange. That was its random color. So a lot of times we'll use loops to look at all of the entries in an array. We might start out setting an index variable, in this case some index, to 0, and then while our index value is less than the length of our array, we can update all of the values. Set them to a random color, increase our index so that we're looking at the next entry in the array, and continue with our loop. So after we run an initialization routine like that, we might end up with something like this, where we have all these different colors in our color array. Now, if we want to read those colors or update those colors, we can do so in our code. I could set a variable named myColor equal to whatever is in index position 5 of our color array, which is green, right? He says it's green, I believe it, or her. Now, to set my color to pink, I could use the index position 1 of the color array to set our color. We could also search through the array to see if we could find green anywhere in there. If we wanted to do that, we might set up 2 indexes, one for where we find the value and one for where we're currently searching. We'd set both of those indexes to 0 and start looking through our array to see if we could find that color green. And we'll do some code to try it. Now, one thing that we have to be aware of when we're working with arrays and lists is because we specify the length as the number of entries, like 6 entries, but our index values for 6 entries are 0 through 5, we can end up being off by 1. We could use the length accidentally for an index value. That wouldn't work because it's too high of a number. It's outside of the range of our array. And -1 would not work either because it's too low. So we could be off by 1. Now, in the Runestone Academy thing, they have some really good stuff. Let's take a look. Just real fast. You guys have already done that. Let's get logged in. I have the worst trouble getting logged into this site. I know you guys do too. Sometimes it has good stuff, sometimes it's a pain. So lists, look, we're at the end here. It's section 10, looking at lists. So just like I was saying, a list is a sequential collection of Python data values. Whenever we create a list in some programming languages, the entire list has to fit contiguously in memory. That means that I have to fit all of the entries side by side. I can't split them up into different spots in memory. So I can actually use quite a bit of memory when I'm using lists and arrays. Each of the values that's inside a list is an element. And lists are similar to strings, which are ordered collection of characters, except that the elements of a list can have any type, and for any one list, the items can be of different types. Okay, I want to look at the next screen is where I wanted to go. So list values. When we're working with Python lists, they're pretty self-explanatory. They do a really good job. We don't have as much unusual syntax as we do in other programming languages. So let's look up here. They say that anytime we create a list, we're going to put it in square brackets. So at the top of this, they've created 2 lists. One that just has the values 10, 20, 30, and 40, and another one that has spam, bungee, and swallow. Neither one of those lists was given a name, though, was it? So it would be hard to refer to that data. But we can see that it's a list of things. Now, in the next list, you'll see that in Python, our items don't have to be the same data type. So we can have a string and a float and an integer, and then they even insert another list inside their list. It's nested, kind of like a matrix thing. It's a sublist. Now we can also in Python have an empty list, which is denoted with 2 square brackets, the opening and closing. We can assign list values to variables and pass lists as parameters, and we can do anything with a list that we can do with a variable. Okay, so they've got a little program here for us. They say we have a vocabulary list, iteration, selection, and control. We have 2 numbers, 17 and 123. We have an empty list, and then we have this mixed list with all of these things in it. This program, the first thing it's going to do is print the numbers list. Then it's going to print that mixed list. Then it's going to create a new list using the numbers and the vocab list and print it. So let's see what all happens there. And if you want to run it in CodeLens, we should be able to step through it. So let's click Show in CodeLens. Now in the CodeLens, we're starting at the beginning where we're going to allocate our vocab list. So we click forward, you should see that list set up in memory. It's allocated out there now. Notice how the CodeLens is showing the index value of each item, 0, 1, and 2. It's doing a great job of showing us those things that are in memory. Now if we click forward, we should see our numbers list get allocated. Sure enough, everything's there side by side. Next, our empty list. And lastly, our mixed list. So no matter which list we're looking at, we can find it in memory. If you look at your mixed list, notice how item 3 in our primary list has that secondary sublist with the 0 and 1 entries. Look a little bit more at that next time. Now I can print everything. First I'm going to print numbers, and it found them and printed them. Notice how Python, when you do a print on a list, puts the square brackets around it for you automatically. We can print our mixed list. Now let's merge those 2 lists. We'll see our new list get created in memory. Whoa, that's ugly. How come it didn't copy that stuff down? Well, it didn't copy that stuff down because it has pointers to the memory location where those lists already reside. So now we're going to print them out, and we'll see our new list get printed. Okay, so let's check some understanding. A list can contain only integers. Is that true or false? False. Getting the right answer up here. Let's check it. Looks good. And this next one, we have a list with the entries shown, and then a print len of a list. Let's scroll up here and look at this program first at our len parameter. You guys have used it before when you've looked at the length of your string. We're using the len function now to get the length of our list. So for this 3-1, let's check it. I want to run this one first. I'm going to save it and run it. It prints out a list length is 4. 1, 2, 3, 4 entries. Then the next one, what's it going to print? It says 4. It has 1 entry, which is a sublist. The middle entry with all of the cheese types or cities or whatever that is another sublist. Then the number 1 and spam is a value. So those are our 4 entries. Spam, 1, the Brie sublist, and the 1, 2 sublist. So for list 3-1, what's printed by the following statement? Is it going to be 4? Our magic marker says 1, 2, 3, 4. 4 looks good. 5 looks good. 1, 0, 1. No, I don't want to start counting with 0, do I? Just when I'm using an index, when I'm counting the entries, I'm going to start with 1. 1, 2, 3, 4, 5. We've got 5 commas and we don't have any sublists, so each of those is going to count as their own entry. What about the next one? We have 367, cat, a sublist, an empty sublist, 3.14, and false. So I count 7. Is that what you counted? Yeah, that looks good. Now, when we want to access our elements, we're going to use a couple of different things, but mostly we're going to use that index location, that pointer position into our array. So let's look at this example. We have an array of numbers, 17, 123, 87, 34, 66, 83, 98, and 44. First of all, if I print out numbers, index location 2, which number is going to print out?
87.
The 87? Do you guys agree with him? Is he right? Looks right. What about the next one? 9 minus 8. That's going to give us a value of 1, 123. And then what about negative 2? And then what about numbers minus 1? Length of numbers minus 1. 1, 2, 3, 4, 5, 6, 7. You can get 6. You're going to get 44. Let's run it. Now I want to step through and show it in the code lens so that we can see that negative action. So we're going to start out allocating our array. There it is. I'm going to print out the number at position 2, number 87, perfect. Now I want to print out the number at position 1. Now numbers negative 2. Yes, sir.
Is it negative 2 like on the list? It's like on the front, right?
It's on the list because no other programming language works that way. So whenever you do a negative number, you're starting at the end of the list and working your way back towards the beginning. So that's why this one, let's see, negative 2 gives us our 87. Sorry, I went backwards instead of forwards. I'm like, what's wrong? I'm going the wrong direction. I'm clicking on the wrong direction. That would be the problem. I'm ready for some turkey, huh? Okay, so this last one. We're starting out with the length of numbers, which in our array length is 1, 2, 3, 4, 5, 6, 7. Then we're subtracting 1 from it and using that as an index location into our array. So we should be looking at index position 6 in our array, which gives us that 44. Okay, what about this next one? What's printed by the following statements? One, 2, 3, 4, 5. So that first one wants to print that empty list. So is it going to be A? Sounds good. The empty list is at index 4, 0, 1, 2, 3, 4. And we're printing out position 5, 3.14. Nobody died. It was okay. Now, what about the next one? What's printed by it? We've got 1, 2, 3, 4, 5, 6, 7 entries. We want to print the entry at index location 2 in uppercase, 0, 1, 2. So should we get cat in uppercase? Looks good. And then this last one is really big. We have 1, 2, 3, 4, 5, 6, 7 entries again. This time, we want to print the entry 2 from our list 0, 1, 2, but then they want to print position 0. So whenever we're working with a two-dimensional array, we're going to have the outer array first, and then that inner array is going to be our second index. So is it going to print the C or an error?
C.
Will it do C? Did you try it?
Yes.
He tried it for me, so I didn't have to. Yay! Okay, so more of that for you guys to go through. But I wanted to write some symbol programs together. So let's open PyCharm. It's trying. I found samples before I came up here, but I don't see them. Come on. He's fixing me. I should just write one, but I'll mess it all up. You guys are just going to have to think of it on your own. All right. So let's create a new program here. New Python file. We're going to call this one array of names. That is some a little bitty font, huh? Okay, so our program and some comments. What do you want to collect the names of? Do you want to collect the names of favorite games, favorite TV shows, favorite movies? Let's do movies, since he saw that Will Ferrell movie this morning. We're thinking movies here. So I'm going to start out with an empty array called list. Let's create a variable called continue, and we'll set it equal to y. And then we'll do a while loop while continue equals y. Now I want to prompt them for the name of their favorite movie, but I think it would be best if I prompt for the first one outside of the while loop. So I'm going to go to before our while loop and use, we'll call it fav equals, we want to use our input command, and we want to prompt, please enter the name of a favorite movies. So not your favoritist, but one of many. Now, when we're working with lists in Python, we have a lot of different methods that are available to us to work with that list. To add new items to this empty list, we're going to use the append function. And what we want to append then is whatever the user said was their favorite movie. Now we could do something nice like let's print out a message, movie added to list. Continue. My input statement is a little angry. How about yours? A little bit. I'm trying to think. I'm wondering, am I using some old Python code here? Let's put this continue y/n in our input statement. It acts like I'm missing a parenthesis, and why is this code unreachable? So mine is mad at the while statement is where it's starting to be mad. It says colon expected. So I guess I can just say while continue. Nope. Let me see. What in the world is it not like? You think that's why it's yellow?
Yeah.
Let's make it COMT then. Looks much happier. While is a built-in function, but I want that one, so I'm okay with it. Seems much better. So I'm going to move this continue YN back the way I had it before because I want to do it a little differently than we've done all of our others just because we can. So that you wouldn't look at code like that and think that it's wrong. Now my input I should just be able to make empty and then it'll be an input based on that previous prompt. Now if we get a Y again, we really want to do that cont.lower so that we know it's a lowercase variable value, and then that should continue with our while loop. So do you want to test it? Let's run it. We should be able to print some things out after this is done. We don't have any functions or anything in this program because we're trying to focus on arrays. So let's run it. And I get, please enter the name of a favorite movie. Oh, it added to my list and I pressed enter on a blank line. I'll have a blank one, but I want to say yes. Gone with the Wind, right? That's always a great one. Well, it did something, but then it just finished and didn't prompt me again.
The while above the favorite input.
Uh-huh. We just need a more input, huh? Well, let's just copy it because we wanted that one outside of our while. And then we want to prompt again at the end of our loop. So very good. That's why it's not doing anything. And we always want that initial prompt normally outside of our loop because that's our priming read. And remember, you might not see that in some textbooks. Those textbooks aren't as good as others because a priming read is very important. And I've had lots of students where I can say, why did you not do a priming read? It would get rid of this break statement that you have in your loop. And then, oh, yeah, it would. So it's just a good programming habit. But that means that we have to duplicate that line of code there at the end of our loop. So let's run it. Now we should continuously get prompted. Yes. What's another movie? Elf. Yes. I can't think of movies today. It's a hard day. Some movie. And then I'm finally going to say no. And our loop should end. Oh, it didn't. I know. I just am not doing things right today, am I? Just one of those days. Up here?
Yeah.
We can do that. But then if they don't want another one, I think we're just going to have to put an if statement in, don't you? If CONT equals yes, which is really dumb. I'll make you guys think of a better way to do it. You can. Now, does that look better? Because I didn't like the way that was doing things. I'll do some movie here. Yes. Elf. No. And it should end appropriately. So a little bit more than what we need in there. Now, when we come out of that while loop, let's print out that list. And we saw that Python would let us do it pretty easy. We can just print our list. I can't even print today. Yeah, I'm wondering if that list name is not a good name to use too. Just getting all these things that sound so good to me, and there's the reason, because they're reserved. Gone with the Wind, yes, I want another one. Elf, no, that's it. And then we should see both of our movies printed out. I like to do that a little bit better, though. I think I want to print a heading. Print original list. And then what else can we do with our arrays when we're working with Python? Can we sort them? Can we ask Python to sort them? Let's look. If I type my array name, list, and then the dot, I'm going to see all of the helpful messages for all of the functions that I have for an array. I've got print and par and all sorts of things. Oh, there is a sort. There's a reverse. So let's try some things. Let's try list.sort. And now I want to print out that this is the sorted list. Try it. Put in your movies. I'm going to put in a few else. 3 is enough, and I'm going to say no. But do put in enough that you can see the sorting change the order of your array. So mine started out with elf at the end and ended up with elf at the beginning after the sort. Now I saw whenever we did that list and followed it with the dot, we have a lot of other things that we can do. We could reverse our list. Let's try it. List.reverse. And then let's print out reversed list. And print our list. And we should see everything backwards. At least our entries. So let's put some movies in. And finally, I'll say no. And we should see our list in all those different ways. So first we have our original list, and then our sorted list. And then our reversed list. Why is gone in 60 seconds at the end of our sorted list? Where Gone with the Wind is at the beginning, or at least mine. How's your list like that? Can you tell a weird difference? Why is Gone with the Wind sorted to the beginning and Gone in 60 seconds sorted to the end? When they both start with gone.
Oh, the capital letter.
So what's our sort order when we're looking at capital letters versus lowercase? We could go look at that ASCII code chart, right? Let's go look. Our ASCII code chart, which is also in our book, don't forget. Try to find one with some numbers here. So sure enough, looking at our code chart, our uppercase letters start here at ASCII number 65. Here's all our uppercase letters. And then after that, at ASCII number 97, starts our lowercase letters. So the uppercase G sorted first, then the lowercase e, because that came before the lowercase g. That makes sense. Sometimes our string sorts can be a little confusing when we first look at them until we think about it. So, be that way. So that's awesome. We have all of our array stuff here. Now let's try a couple of other things. Let's do list.clear and then print it. Are we going to have anything left? I'm going to do some lowercase and uppercase things since that was interesting, and say no, no more. And so I sort my list and reverse my list, and then when I clear the list, it's just empty. So list.clear will empty out all of the entries. Now, I don't really want to keep my list up clear because I'd like to keep those entries in my array. So I'm going to comment out those 2 lines for now. And let's do a for loop to look at all the entries in our array. Now we know we can just use that keyword print, and we can just print out that list or our array, but sometimes we need to loop through an array to know what all entries there are. So our for loop is going to be what? What do you want it to be? For what? For word in list. We can do that. You want to try it? That's pretty simple syntax, isn't it? Python's just super helpful like that for us. Now let's print word is a literal, so we have the word word, and then the word that Python is looking at. Let's make sure that it's actually handling it the way we think it should. Before we do that print, words in for list. So I'm going to run it, put in my movies. So whenever we use the for list, it did it exactly as we thought. Entry number 0 was gone in 60 seconds because of my reversing. Entry number 1 was ELF, and entry number 2 was Gone with the Wind for me. So those were my movies that I had. So let's try another for loop. What if we do words in for list with index? So for this one, instead of using word, which makes perfect sense for our situation, let's say we want to number these words. So we're going to start out, let's use X count in range 0 through list dot. How can I tell how long it is? You guys in all of your test stuff said to do it this way. Length of our list. So we can control our loop using our list itself for how many entries, how many times we want to execute our loop. We know that the length property, that length function, will tell us how many entries are in that list, so we can use that to control our loop. So for this one, let's print out word, £, and then I want to add X count as a variable. And I'm using the commas because I don't want to convert things to strings. I'm going to put a dot after the number. And then the last thing that I want to print out is our list property, but this time we're going to use our X count variable as an index pointer to specify which location in our list we want to print. So that should be very similar output, just a little bit different of code. Output should be about the same. Let's try it. Yes, I want more. Gone in 60 seconds. Yes, I want more. Else. No, I don't want more. So we got that extra spaces there because I used those commas to output things in the print statement. Remember, commas will automatically include a space for us, which doesn't work really good here. But now I can see that I have a counter along with the different entries in my array. So if I use the for loop with a count type option, I can have access to which index value we're currently looking at. In our previous example where we used this really handy for word in list syntax, we don't have that counter available, so we don't know which entry we're working with. Looks good. I could fix that a little bit. Let's fix it. I want, after my pound sign, my hashtag, I'll put a plus there because that extra space is looking bad. I don't want to do a sum of X count. I want to do, sorry, I got buzzers going up here and everything's going crazy. Now I have to replace every one of those commas with a plus. If I want to change it to be that way. Now I'm going to run this. Gone in 60 seconds. Yes. Elf. No. And now our final list looks pretty good. Word number 0, that doesn't usually carry a lot of meaning to users. So normally when we output things like this that have a basis in an index value, we'll add 1 so that we're not outputting number 0. The more we get used to having computers around everywhere, the more we're used to that. But a lot of people still like, what? Laugh at us. On with the wind. Yes. On in 60 seconds. Yes. Elf. No. That list looks pretty good. So we can get that nice numbered list out by using the count property in our for loop. So lots of different options that we have. Now we'll work a little bit more after Thanksgiving with some arrays. For now though, I'd like to do a different activity. We're gonna get you guys all up and separated and get you out of here for Thanksgiving. Let's try it. I hate doing this with hardly anybody here. What have we got going on? Let me make sure I've got a list of attendance here before we go any further so I can give you guys points. I guess we need to have, I'm going to pass around this pop quiz. This pop quiz will give you your points if you write your name in the right place. Okay. All right. You guys Okay, I want to get these ready for you guys. What I've got is these giant Post-it notes, and we've got some code snippets. Like this one has two, but I really cleaned up. So these code snippets are little teeny pieces of code like loop or an if statement, and most of them, this one, no, this one is most of them will output something. So we're going to split up into partners, and I'm going to give you and your partner your own color of Post-it note. You're going to walk around and write down what the output is going to be. On the back of the Post-it note, so people can't see your answer, you're going to stick your Post-it note color to the giant Post-it note. So we're going to see which color has the most right. No get extra hot quick point.
It'd be random.
That one out there is no good. I was working by us. Yeah. Oh, wait, and told somebody else.
I mean, I get that one's hard to watch, but I mean, I've watched these like.
Each team is going to answer each one, and then at the end we'll check answers,
And then you do.
so we can see who got them right.
When you get to start creating your own steps, otherwise, so sorry if you have talked if you're hired. First number's take the second number's hired.
So let's see, we need one more spot. So how should I split my,
Should number us off 1 and 2.
1 and 2, 1 and 2, 1 and 2. I want you to line up somehow hard. Is anybody going anywhere for Thanksgiving? Everybody staying home? You're going somewhere?
I can't afford to.
Okay, so we're going to start. Everybody who's staying home for Thanksgiving is up here. And I want you to line up based on how far you're going to travel. So our person who's going to travel the furthest will end up at the end. If you're all going to stay at home, you have to kind of fight it out. Decide. Nicely. How far are you going? I'm not going anywhere. I would stay right in the front.
I made a which is on white.
Come on, you guys, line up. We're waiting for you. We're waiting for this front row, I tell you. Did everybody get it signed?
I think so.
Okay, y'all got it. Why are you going to kill Python?
What?
Why are we going to kill Python? Okay, we're lining up by how far you're going to travel for Thanksgiving. Huh? Not, today is just not a good day for thinking. That's why we're going to do this. Okay, everybody's figuring it out. Let's see if I've got some.
Stratford.
Okay, yeah, that was looking gross.
Okay, I'm going to do, like he suggested, and just do 1, 2, and you're a team. 1, 2, you're a team. You guys are 1, 2, you're a team. You guys are yellow. Now, write on the back of the Post-it note so that when you stick it, people don't see how you answer. Oh, I'm sure to be done. Okay. I know you are. Who are you with, Kim? You left? Okay, so you got a color. Okay, keep watching. Make sure I don't give anybody the same color as I gave you. Like, we have some leftovers. Are you two together? Okay, that's all right. There's some more. And 1, 2. Have I given anybody this out?
Okay, consequences of being a band kid.
You don't want to be duplicated.
Everyone pops their it's you're not a band kid if you don't.
The ones with the rounded edges
I saw stuff on the back.
That's a milestone. No one was ever that generous.
that'll work.
You know, probably not as a band is almost like cussing in the meeting. Like, if
All right,
you don't
ready?
do it, you can't be trusted.
All right.
Sorry.
Okay, go to a place where there isn't anybody. You just kind of keep going around and get it till you got them all.
We're just getting stomped. Do you know which one for us to sign in our names?
Uh-huh.
Hey, Miss Riley. I don't know what that does. Do we write syntax here? So we have a range for 11. So we have Wait, what do we write?
You guys, some of the print statements are the older release of Python that don't have parentheses around them. So just pretend they have parentheses, that they're right.
Yeah. I remember her too.
One team on one seat. Get. Second team, there's a seat over here. There's a sheet on the door. Isn't there? No, you're writing what it's going to output. So is that one going to output anything? That would be a good thing to write. Yep, because that one is not a very good one. We need more. See, I need another one. It's a good thing we have so many people gone. Yeah, we have a.
Not everybody's here. Like, everybody's here. So we have to replace it in order. So if we got 1 to 11, you've got X, Y, so this is X times Y.
Rearrange.
Yes. But we still have the range of the numbers on 1 to 11. So we'll never get to 1. Oh, wait, I just thought about that. Yeah. So, I don't even know I said that. X times Y. X times Y. Well, that's not. It's just saying it like twice.
Yeah, it just equals itself.
Yeah.
So it's just figuring out what it's printing.